Hi everyone, welcome to today's video on three-dimensional vectors. We're going to be looking at the basic skills that you need when manipulating three-dimensional vectors. We're going to be looking at addition, subtraction, multiplication by a scalar, and how to find the magnitude of a three-dimensional vector. Really nice thing is you put in lots of work already with two-dimensional vectors, and a lot of the approaches here are almost identical, except we are manipulating three components as opposed to just two. We're going to go straight into this example on addition. All the examples today are going to use the same two vectors, u and v, and you'll see those on each of the slides. Okay, so with addition, same as with two-dimensional vectors, we've got essentially a little bit of substitution to get started. So we are going to replace vector u with vector u's components. So they are, in this first example, 3, 1, negative 2. And to that, we are going to be adding vector v. So again, just replacing the name v with v's components over here, which are negative 5, 0, and 4. Okay, like two-dimensional vectors, when we are adding, we've got to add the corresponding components. It's just that we've got one extra this time. So in this case, we're going to have the top component added, the x component, then the middle components, the y components, and then the ones at the bottom, the z components. We're adding, we've got some negatives here, so we're going to just go through these one at a time. 3 plus negative 5, adding a negative, it's going to move us down our number line, so we end up with an x component of negative 2. 1 plus 0, nice and straightforward, still just 1. And we've got negative 2 plus 4, moving up our number line from negative 2, 4 spaces, takes us to positive 2. Simple as that. And we've got the components of the resultant vector of adding u and v together. On to subtraction, and we saw that with two dimensions, a wee bit trickier when we're doing it with a diagram, but just subtraction whenever we're doing it in component form. V minus u, so we've got vector v coming first this time. We're going to do that same kind of substitution, so negative 5, 0, 4. And we're subtracting from that vector u, which is 3, 1, 2. Oh, negative 2, sorry. And then we are subtracting these, so negative 5 subtract 3 goes further down our number line to negative 8. 0 subtract 1 takes me down to negative 1. And here at the end we've got 4 subtracting a negative. So 4 subtract negative 2 means we're adding that 2 on. So we end up at 6. Okay, so that's addition and subtraction. You'll see all the similarities there between these three-dimensional skills and the ones that you learned last lesson with 2 dimensions. Okay, next example. We are looking at multiplication by a scalar. Not only that, but we're going to build it in to a kind of slightly bigger question as well, where we are going to subtract the result of these vectors once they've been multiplied. Okay, again, you've seen this kind of question in 2D, so just looking at the differences and similarities between the 3 dimensions and the 2 dimensions. We're going to start by doing our substitution. We're going to take the name of the vector and replace it with its components. So we've got 3 lots of 3, 1, negative 2, and we're subtracting from that 2 lots of negative 5, 0, 4. Remember, we related this to distributive law, like you're multiplying out a set of brackets where everything within the brackets gets multiplied by the value in front, this scalar. Okay, so we're going to do multiplication first, again remembering our order of operations, multiplication happening before subtraction, and so we're going to go with each component multiplied by 3 in the first case, so we get 9, 3, negative 6, and for the second one we are multiplying 3 by 2, so we get negative 10, 0, 8. Now that we've done our multiplication, we're going to finish off by doing our subtraction. And again, we've seen subtraction in the last example. We're just remembering which components go with which. So top with top. So 9 subtract negative 10. So subtracting that negative like addition. So 19. 3 subtract 0, still 3. And negative 6, subtract another 8, takes me all the way down to negative 14. And there are my resultant vectors components. Okay, so multiplication by a scalar with 3D, just as straightforward as with 2 dimensions. All right, last question. we're going to be looking at finding the magnitude of a vector in 3 dimensions. Okay, if you remember when we did this in 2 dimensions, we related it to Pythagoras. I drew out the vector. I'm not going to do that with this because it's a little bit more complicated to draw a 3-dimensional vector, and I think it would probably be more confusing. So instead, we're just going to look at the similarities. It is still Pythagoras. It's the equivalent of finding a space diagonal using Pythagoras. We're just going to look at how simple we can make this process. Essentially, if I want to find the magnitude of a vector, in this case, vector u, I know I'm finding the magnitude because of these 2 vertical lines. That's the notation that I'm finding the size of u. All we're going to do, same as 2 dimensions, we're going to take our components one at a time. 3, 1, -2, and we are going to square each of them. Again, with negatives, I like to have a wee bracket around there to remind me what's going on. Once we've squared them, we are adding, and then we square root the result that we get. Okay. Few lines to work this out. Again, you can use your calculators here. Once we've covered the topic of surds, you might look at doing this slightly differently, but we're just going to use our calculators for this just now. So we've got 9 plus 1 plus 4, -2 squared being +4, and we're adding that +4 here. This gives me the square root of 14, and I'm just going to type that into my calculator. Let's have a quick look at this. So we've got the square root of 14, and that gets me a big, long, irrational number, 3.74165737. I'm rounding it to space again. I would usually write this down unrounded and then round to 1 decimal place. I'm going to go straight to that just now, and I get an answer of 3.7, and that's units. Again, no context to this, so I'm not sure what the units are. Could be displacement, so maybe in meters or kilometers. It could be a velocity in miles per hour or kilometers per hour, something like that. But because I don't know, I'm just writing units at the end. Okay, that's the 4 main skills for you to be practicing: addition, subtraction, multiplication by a scalar, and finding the magnitude, all now of 3-dimensional vectors.